studied about rectilinear motion, that is motion in only one direction, either x or y. In this video we will discuss about motion in two dimension, that is motion in plane. Consider one example. Initially at time t1 particle is at position p, and after some time at time t2 particle at position q. Here at time t1 at point P, particle cover distance x1 along x-axis. That is, this x1 distance particle cover along x-axis. Also, particle cover y1 distance along y direction. Means P particle or object moves along two direction. That is, of this motion of the particle is along two dimension, that is motion in plane. Such type of motion is called as motion in plane, and that plane may be, this blackboard is one plane, or your page of your notebook or page of your book are plane. Now we have to calculate displacement. Here suppose at time t1 particle is at position p bar, and at point q particle displaces and its displacement x2 bar. Now here we can denote displacement by vector because it contains two components, that is along x component and y component. Suppose at position p particle having displacement x1 bar, and x1 bar denoted by x1 I cap plus y1 j cap. Here x1 is the position of the or component of the displacement along x direction, and y1 is the position of the displacement along y direction, and I cap and j cap are unit vector along x axis, and j cap is the unit vector along y axis. So at t1 displacement of the particle is x1 bar. Similarly at t2 particle having displacement x2 bar, which is equal to x2 I cap plus y2 j cap. This displacement is x2 and this displacement is y2. Now we have to calculate displacement, this displacement, that is displacement pq, which is also vector quantity, which is denoted by delta x bar, which is the difference between two displacements. We can subtract component of the x into I cap plus subtraction of the components of the j cap, that is components along y direction, into j cap. Therefore delta x bar is equal to x2 minus x1 I cap plus y2 minus y1 j cap. Now we have to calculate average velocity. In last lecture we have studied about average velocity. Average velocity is equal to change in displacement upon change in time. Here change in displacement is equal to delta x bar. Now we have to divide this quantity by change in time, that is t2 minus t1. By dividing whole this term by t2 minus t1, we get two components of the velocity, average velocity also vector quantity, and which gives x2 minus x1 upon t2 minus t1 I cap plus y2 minus y1 upon t2 minus t1 j cap. That means this quantity is average velocity along x axis, and this quantity is average velocity along y direction. Therefore average velocity can be expressed as v average is equal to v average along x axis I cap plus v average along y direction into j cap. Now we know magnitude of vector calculated by under root of square of ith component plus square of j component, and this direction denoted by tan theta is equal to vy upon vx. These concepts are we are already studied in second topic, that is mathematical methods in physics. You can watch that video and then come here. Now instantaneous velocity. Instantaneous velocity means velocity of that particle at any instant. Suppose we have to calculate velocity of the particle at any point on this curve, then we can draw tangent to that point and find out instantaneous velocity, and slope of that tangent it is dx bar upon dt. Therefore instantaneous velocity is denoted by v bar, which is equal to limit delta t tends to 0 del x bar upon delta t, and it can be denoted in vector form, which is equal to dx dt I cap plus dy dt j cap. Next definition is average acceleration. In last videos, for rectilinear motion we already studied about definition of the average acceleration, that is, it is change in velocity upon change in time. Here change in velocity is v2 bar minus v1 bar upon t2 minus t1. Here v2 bar is vector, that is it having component of along x axis and along y axis, and v1 bar also having component of x bar and y axis. Therefore it can be calculated like this: v2x minus v1x upon t2 minus t1 I cap plus v2y minus v1y upon t2 minus t1 j cap. This quantity is average acceleration along x axis. This quantity is average acceleration along j axis. Therefore we get average velocity is another vector. Sorry, we get average acceleration, that is, which is new vector and denoted by average acceleration along x axis plus average acceleration along y axis. Now we have to calculate magnitude and direction of this vector, which is given by magnitude of this vector is equal to under root of square of component of acceleration of along x axis plus square of component of acceleration along y axis, and that is direction given by tan theta is equal to ay upon ax. And now instantaneous acceleration is denoted by a bar, which is equal to limit delta t tends to 0 delta v bar upon delta t, which is equal to dv bar by dt, which is again a slope, which is can be write in the form of vector like dvx upon dt I cap plus dvy upon dt j cap.